Hey everyone, welcome to JavaScript Fundamentals. In this video, we will learn about how JavaScript handles asynchronous code execution using event loop. Let's start with the basics. What is event loop? Well, the definition would be the event loop is a fundamental part of JavaScript that ensures non-blocking asynchronous operation. And it is a never-ending loop in case of browser. So the algorithm of event loop would be this. This involves call stack, micro task queue, task queue. Well, these things are these things are related to event loop, and event loop actually checks whether there is something in call stack or not, and if call stack is free, then it will pass a micro task queues item one by one, and when the entire micro task queue is completed, then it will pick one item from task queue, and if call stack is free, then only it is pushed to the call stack. Otherwise, it will keep executing micro task queue. Well, that's about event loop. Now we will went through some examples that will prove our concept. Let's take the first example. So this is a main function in which there are 4 lines. Like line 1 is simple, line 4 is simple, but let's focus on line number 2 and line number 3. Well, let's see. First of all, let's see its output. Then we will understand here how it works internally. Okay. Just to show you code and output together, I started the debugger in Edge browser. So let's play. So task 1, task 3, and after 5 seconds, it will print task 2 as expected. So now we will go through how it works internally, how it call stack works. So let's first revise the algorithm again so that we can understand the process. Well, in one iteration, first of all, one by one, all function callbacks of promises will be pushed to from micro task queue to call stack. In one iteration, from here to here. If call stack is free, then only. And afterwards, when everything is being executed, then it will pop up only one task from callback queue. From here, only one task. And it will push to the call stack if call stack is free. So now let's focus on our example. So first of all, global execution context will be pushed to the call stack, and it will push main function, and main function will push one by one, and it will execute it. So like the first one, it is task 1, document.write task 1. It will post it here, and let also create one browser window here. So it will print task 1, and here it is just being initialized. Task 2 is defined with this function, so just got initialized, so nothing else. So afterwards, this line set timeout task 2 2000. What does it mean? It means that call it the relevant API present in the browser and register the timer for 2000 milliseconds. Just does that only. Register it and move to the next. So it got registered and it moved to the next point. Next is print task 3. Okay. So obviously it will be popped out, and then it will push in document write task 3. And it will print here task 3, and afterwards, when 2 seconds got completed, so when task 3 got printed, when the execution done, then it will exit, right? So when the execution is done, so what it will do, after 2 seconds, the web API will push task 2 in the task queue, also known as callback queue. And our event loop will check whether there is something in the call stack or not. And if call stack is available, then it will push task 2 here. So document.write task 2, this line, it will be get executed, and here. So that's the reason task 2 got printed last. Now we will focus on the next example that include promises also. In next video, we will learn about what is promises. So let's quickly understand how it will work. This is second example that includes promises also. Means fetch is a promise, and we have in fetch.then we have included task 3. Alright, so now see what it will print. Let's play it. Task 1, task 4, then task 3, task 2. So what was the order? Task 1, task 4, then task 3, and then task 2. Means it simply what it did, it line by line, it printed first of all this, and it registered the timer, it registered the fetch API also, and afterwards it's printed task 4. That's the reason task 1 and task 4 got printed first, and this was in the first iteration of. And in the next time what happens, so afterwards it's checked. In the micro task queue there was fetch and fetch is callback, and in the task queue there was task 2, and we know that micro task queue are of higher priority. So that's the reason this task 3 got printed first, and afterwards task 2. With graphics also I will make you understand. Now let's see what will happen for the second example. First of all, our global execution context will be pushed to the call stack. Afterward, this main function, and this main function will execute the thing one by one. Like first of all, it will print task 1. Afterwards, it will initialize this task 2. Afterwards, it will register the timer of 2000 millisecond here, 2000 millisecond, and afterwards again initialization, and afterwards again initialization. Sorry, not initialization, registration to the web API called fetch to go to this URL and then fetch, and afterwards this task 3 will be executed. Means afterwards, not in this execution flow. In this execution flow, only registration is happening. Okay, not the execution. It means only registration. Okay, and afterwards there is document.write task 4, so it will print task 4. So now after 2000 millisecond, set timer will post it here, task 2, and let's suppose in 1.5 millisecond we got the API result. So afterwards, this task 3 got executed. So the web API fetch, it will push task 3 to the micro task queue here. And in the next iteration of the event loop, first of all, we all know that it will it check one by one. It pop-ups all the function callback or promises from micro task queue to task to call stack. Okay, so first of all, it will move task 3 here and execute it. So that's the reason. Afterward, we see task 3, and when everything got executed in micro task queue, then it will only execute one item from task queue in that iteration. So task 2 will be pushed to the call stack, and it will when it got executed, it will be here. So that's the reason this order: task 1, task 4, task 3, task 2. Hope you learned something from my video. Thanks for watching. Please like, share and subscribe.